Okay, today we're going to be doing Chapter 9, Lesson 2, and we're going to start focusing on geometry concepts, but we are also going to be connecting them to the algebraic ideas we've been working on. The first thing we're going to do is, I think, review classifying triangles. Now, this may be something that was brought up last year in 5th grade. It could have been right about the time that we started working from home. This is something that you also learned in 3rd grade and 4th grade, but we're going to review these ideas about angle sizes and how they're used to name and classify triangles. Okay, so the very first thing we need to know is that triangles always have two different names. One of the way we classify and name angles, classify and name triangles is by their angles. Okay, so we have acute triangles, right triangles, and obtuse triangles. So what we need to do is remember what the word acute means. What size would an acute angle be? Answer that for me, please. Okay, so if you answered less than 90 degrees, you are correct. So this particular triangle here, uh, every single angle is less than 90 degrees. So this is going to be called an acute triangle. Okay. Now, let's talk about right angles. This particular angle here is a right angle. What is the size of a right angle? Go ahead and answer that for me, please. If you answered exactly 90 degrees, you are correct. So this right angle, another way of looking at this, it's like the corner of a square. So you can see the symbol is like a little square symbol that indicates something is a right angle. So this is a right triangle because it has one right angle. And finally, we have obtuse triangles. Obtuse triangles have one obtuse angle. Go ahead and answer this question. How big is an obtuse angle? If you answered any angle that is greater than 90 degrees, you are correct. So basically, acute angles are always less than 90 degrees. And then we have right angles that are exactly equal to 90 degrees. And then we have obtuse angles that are always greater than 90 degrees. These are three things we need to remember, and we started learning these concepts in 3rd grade, and I think we attached the idea of 90 degrees in 4th grade. But if you have all acute angles, acute triangle. If you have one right triangle, you have a right angle, you have a right triangle. If you have one obtuse angle, you have an obtuse triangle. Getting tongue twisted. Okay, so the other way of classifying triangles is by the length of their sides. Okay, so you'll notice these dashes here. I'm going to start over here, and if you'll notice, this particular triangle, doesn't it look suspiciously like this triangle? And you'll notice that all three of these triangles here are angles here are equal. And do you see how this has the equal sign for all three sides? Those are congruent sides. If all three sides have the same length, those are called congruent sides. And that makes it an equilateral. The word lateral means side. What do you think the word equal means? I don't know. Equal? So an equilateral triangle has all three congruent sides. And it just so happens that if all three sides are equal, then all three angles are also going to be equal. Okay, so this is an acute triangle. It's also equilateral. This is an acute triangle. It's also equilateral. Now let's look at the isosceles. You'll notice that this dash and this dash are the same. That means that two of these sides are congruent. So this is called an isosceles triangle. In this particular case, we could also call this one what based on its angles? Go ahead and answer that for me, please. Okay, all three of these angles are all acute. So in this case, this would also be an acute triangle. So this is an isosceles and an acute triangle. Now here's an interesting fact. Are two of these sides equal? Yes or no? Yes. If two of these sides are equal, this is also called an isosceles. So an equilateral triangle could also be identified as an isosceles triangle as well. But can an isosceles triangle be identified as an equilateral triangle? No, not always, because this particular side here is not equal. So you just have to think carefully about what you call a if it has equal sides, two equal sides, automatically isosceles. Three equal sides, it's isosceles, but it's also, if it's three equal sides, equilateral. Okay. Finally, we have the scaling. This one, and this one. None of the marks are equal. All three sides are completely different. That is called a scaling. In this particular case, if this is a right angle, this could also be called a right triangle based on its angles. So this will have a second name if we look at the angles as well. But this is definitely scaling because all three sides are not equal to each other. They're all completely different. We just have to learn this vocabulary and memorize it. Every triangle has at least two names. Okay, these next two examples are done for us already. It says to classify each triangle by its angles and by its sides. So we're going to give it two names. And let's start by talking about the sides. 1 3/10, 2 5/10, 2 1/10. None of those are equal. There are no equal sides. All three sides are different. Okay, if all three sides are different, this is definitely going to be a scalene triangle. Now, if you'll notice, though, this does have a right angle, so it's going to be a right triangle, and it's a scalene triangle. So one right angle makes it a right triangle. All three sides different make it scalene. And if we look at this particular triangle, this is very familiar. All three sides are equal because the dash, 1 dash, 1 dash, 1 dash, that indicates all three are congruent. And then we have all three angles that are exactly the same measure. And they're also less than 90 degrees. So this equilateral triangle is an acute equilateral triangle. All equilateral triangles are acute. Okay, so looking at these two examples that are not done for us, I noticed that this first triangle has two sides that have an equal congruent mark, and then the third side is not equal to those other two. What is the name of that triangle by its sides? Go ahead and answer that for me. Okay, now we notice that if you said scaling, you're wrong. If you said equilateral, you're wrong. This only has two sides that are equal, so this is definitely going to be an isosceles triangle. And by its angles, you can see that isosceles triangles do have two equivalent measures of angles, but this one here is greater than 90 degrees, which makes it what kind of triangle by its angle measure? Answer that for me, please. Yes, that is definitely an obtuse angle, so that's an obtuse triangle. In the second example, you notice that all three sides have different lengths. So what kind of triangle does that make it by its side? Answer that, please. That's definitely a scalene because all three are different measures. And if I'm looking at each angle, 72, 67, 41, they are all individually less than 90 degrees. So what sort of triangle is this? If you said acute triangle, yes. An acute triangle doesn't have to be equilateral. This is definitely scalene, but every single angle is less than 90 degrees, so it's definitely an acute angle. Definitely an acute triangle. My tongue is twisted today. Sorry about that. Okay, so now here's where algebra connects to the geometry that we are reviewing. It's important to know the sum of the angle measures of a triangle is very, very specific. You have to memorize this, that if you add every single angle on any triangle ever in the history of the world, in the existence in the entire planet, all of the angles will add up to 180 degrees. So x plus y plus z is always going to equal 180. So that is a fact that all the interior angles of a triangle always add to 180 degrees. And we're going to use that fact to solve for missing angle measurements using algebra. Okay, you can write and solve equations to determine missing angles and angle measures. Okay, now, so this first example I've done for you, it says to write and solve an equation to determine the value of x. So if you have 38, 55, and x, we know that all three of these things together equal 180, so that's what we write. 38 plus 55 plus x equals 180. So we combine 38 plus 55 and we get 93. We subtract 93 from both sides, the property of equality of subtraction. We end up with x by itself, and 180 minus 93 equals 87. Pretty straightforward. These are things we've been practicing for a while now. Let's go ahead and look at the next example. We have 17 and 141. We do not know what this x is, so 141, 17 plus x equals 180. Then we combine these two together, we get 158. We subtract 158 to get rid of it. We have to do that to both sides. Then x is equal to 22. Okay, so there are going to be more examples that we will do together, and I'll show you on tomorrow's lesson objectives, vocabulary practice page. There will be more examples we do together that you can watch, and also some videos about classifying triangles as well. For right now, I want us to stop and think, hey, what is the most important thing I need to remember? I'm going to be a hint here. This is probably something important that you need to remember. I'm kind of circling it for you right now. What is something important to know when you finish this notes video to help you complete other problems? Think about that. Go back and look at your notes, but do not say the lesson. Do not say the examples. Please think carefully. All right, so what's the most important thing to remember about this lesson? Thank you for your thoughtful answer. Please review the skills in the lesson objectives page tomorrow, but also come to class. We'll do some practice problems together. See you later. Bye.